Hello class. This is a demonstration on how to use the shift register. The shift register consists of data flip-flops that are cascaded together where the output Q is used as data for the next flip-flop. This means data are entered in the first flip-flop and then these bits are shifted one by one through the data flip-flops after each clock pulse. This is an 8-bit shift register, which means that it will take 8 clock pulses to shift one bit of data from the first flip-flop to the last flip-flop. This allows you to store up to 1 byte of data in this set of flip-flops. Shift registers come in many different sizes. They come in 4 bits, 8 bits, and sometimes these 8 bits are cascaded together to give you 16 bits and 32 bits. It is important to remember that 1 byte of data is equal to 8 bits. Data can be loaded into the flip-flops in many different ways. They can either be loaded bit by bit, one at a time, or through the preset command they can be loaded into the register all at once with one clock. In this example here, we're assuming that the initial state of the data flip-flops is this binary code here, where the most significant bit here is at Q7 and the least significant bit here is at Q0. Let's make that very clear. The most significant bit will be here, and the least significant bit will be here. So the least significant bit on the binary code is this value, and the most significant bit will be this value. Now we have to be very careful about how we input the data into the flip-flop based on the problem or the question that is given to you. I'm going to assume that I'm going to shift the data into the register starting with this value here, and then I would like to know the status of the flip-flops for different values of clock pulses. We're going to assume that we're going to use 4 clock pulses, and we're going to find out what is the value of the flip-flops, the final binary number of the flip-flops after 4 clock pulses. Now remember, the flip-flops are going to go out, the data is going to go out of the flip-flops by Q7, which means it will go out here. And the data will come into the flip-flops from the least significant bit. If we assume that this is the standard form for the binary value where the most significant bit is to the left and the least significant bit is to the right. However, you must read your problem clearly to find out how the values are displayed for you. Now remember, we're going to enter the data starting with this value first. And we're going to do it for 4 clock pulses. Okay. What does that mean? It means that the first 4 numbers of the register will be moved out. So they will be canceled or they will disappear, which means you are left with 0101. That has moved from these first 4 numbers or 4 positions, and it will be shifted over to the next 4 positions, because remember, we executed 4 clock pulses. Now we need to find out what value got shifted into the shift register. Well, 4 of these numbers, or 4 of these bits, got shifted into the shift register. The first bit was a 1. I'll change color to make sure you understand. And that got shifted over. The second was another 1. The third was a 0. And the fourth was a 1. So, the final state of my flip-flops, if I consider the left side as the most significant bit, or Q7, and I consider the right side the least significant bit, or Q0, this will be the value, which means the output here will be 0, 1, 0, 1, 1, 1, 0, 1. That will be the answer to this question. I hope this gives you an idea of how to solve problems using the shift register. Thank you.